Now we are going to derive one important expression for acceptance angle in the case of optical fibers. Here I have drawn the cross-sectional view of the optical fiber. Here this is the middle portion of the optical fiber. That middle portion of the optical fiber is called core and its refractive index is N1. The core portion is surrounded by the another layer called gladding. The gladding is also a transparent medium, core is also a transparent medium. The refractive index of the gladding is N2, refractive index of the core is N1. And this one will act as a denser medium, and compared to the refractive index of core, the gladding refractive index must be less. The most important thing is N1, that is refractive index of the core, is greater than which one? N2, that is refractive index of the gladding. So this one will act as a denser medium and this one will act as a rarer medium. And then one more medium is there in the outside. Are you clear? Outside the optical fiber, one more medium is there, that is nothing but air medium. Its refractive index should be taken as N3. Now we are going to derive the expression for one angle called acceptance angle. Its definition is given in the textbook. Here I have drawn the magnified picture of the optical fiber, in which I am going to draw the ray diagram. You have to observe it very keenly. So this is the boundary of the optical fiber in which I am going to draw the normal. Are you clear? I am going to draw the normal. Draw the ray diagram neatly. Automatically the derivation part will be very easy. So after drawing the normal, what you have to do? You have to draw the incident ray. So this is the ray which travels from air medium. Are you clear? So this is the incident ray. So it travels from air medium to the core. Here one angle should be drawn. That name of the angle is called IA. This IA is called acceptance angle. So in this particular acceptance angle, the ray must be allowed to pass through. Only then the ray will graze the surface. Are you clear? At a particular critical angle, what will happen? The ray will graze the surface, later it will get total intent reflected. Are you clear? So this must be the angle. This must be the angle called, acceptance angle. Only at a particular acceptance angle, what will happen? The ray will start to graze, later it will get total intent reflection. So after incidence, what happens? It meets that point. After that, here the ray, it travels, after getting refraction, it travels within the core. Are you clear? Now I am going to draw the refracted ray. So this is the refracted ray. It bends towards the normal. Are you clear? So ray travels from rarer medium, that is air medium, to the core, and it bends towards the normal. Here you are getting one angle of refraction that is called as RA. It can be written as RA. Are you clear? Now I am going to draw the another normal here. Now the ray, it tries to travel from this medium to this medium. Here this angle must be, IC. Are you clear? IC means, critical angle. To maintain this critical angle, this angle must be, acceptance angle. Are you clear? That is very important. Here, this angle must be the critical angle. To create the critical angle, what will happen? This angle must be the acceptance angle. Are you clear? Why it is called acceptance angle? Because of this angle, what happens? This angle would be a critical angle. After becoming the critical angle, what will happen? We know very well that when the ray travels from denser medium to rarer medium, what will happen? The ray will graze along the surface. Here in between this core and gladding, there is a intermediate line. Through this line, what will happen? The ray grazes. Are you clear? So very important one. To make the ray to graze, to get this IC, this angle must be acceptance angle. Are you clear? In the definition, they have given the definition in the textbook. Okay, very tough to write and learn. What is mentioned about acceptance angle? To ensure the critical angle, look at that. To ensure the critical angle, we have to split the sentence. To ensure the critical angle of incidence in the core gladding, this is called as core, this is called gladding. Are you clear? Core gladding boundary. This is called core, this is called gladding. In between boundary is there. Here we have to ensure the critical angle. What we have to do? The light should be incident. There they are mentioning. The light should be incident at certain angle. At certain angle means they are mentioning about the acceptance angle. At the end of the optical fiber. At the end of the optical fiber means there. At the end of the optical fiber, acceptance angle is created. Because of the acceptance angle, this angle becomes critical angle. Later ray that it travels along the boundary. So we are going to derive the expression for IA. Are you clear? So here you have to understand one thing, that this N1 is greater than N2. Therefore, this medium will act as denser medium. This medium will act as rarer medium. So according to the condition of the total internal reflection to occur, the ray travels from denser to rarer. Are you clear? Since it is IC, definitely this angle would be, clear, 90 degree. Are you clear? Here the angle of refraction must be 90 degree. Are you clear? So all important things must be drawn in proper form. Only then you will get the answer. This 90 degree should be taken as angle of refraction. Are you clear? So very important one. After that you draw one triangle. Okay, this triangle will be very much helpful for you while deriving certain things in future. Are you clear? So here you have to draw one triangle. From this triangle, is it clear? We are able to analyze certain things. That's why they have given the triangle. So I have taught how to draw the ray diagram in the case of acceptance angle derivation. Okay. So later I am going to derive the derivation. Any doubt on this? So first you have to learn how to draw the ray diagram. Okay. Now we are going to start the derivation. Now I am going to apply the Snell's law when the light travels from air medium to the core. How to write Snell's law? Look at here. Snell's law to be applied when the refraction takes place here, when ray travels from air to core. So I will write it in short form, air to the core. So what is Snell's law? How to write this? N1 sin I is equal to N2 sin R is a fundamental equation. Here, which medium is there? N3 is there. Therefore, instead of N1, we can write N3. Here this angle is called acceptance angle. Therefore, I can be written as IA. Are you clear? So, which medium is here? Core. It enters into the core. Therefore, N2 can be replaced by which one? N1. As per the name we have to write. And then here one angle is there. This is angle of refraction, that instead of R we can write it as RA. So this is the equation which is written when the light travels from air medium to the core. Are you clear? So this is the first equation. Understood? Now I am going to write the same Snell's law for the next refraction. Here ray travels from core to the gladding. So the same Snell's law to be applied when light ray travels from core to the gladding. If you write it like this, it will be easy for you to write the Snell's law. Again, I will write the fundamental formula. N1 sin I is equal to N2 sin R is the fundamental formula. Are you clear? Now I am going to make the changes. Here this one will act as the first medium. Are you clear? Therefore, as it is, you can write it as N1. Are you clear? And then here the angle of incidence is IC. Therefore, it should be written as IC. So ray travels from here to there. So this one will act as a second medium. Therefore, as it is, you can write N2 here. But angle of refraction is 90 degree. Therefore, instead of R, we can substitute 90. I will write it in the next step. N1 sin IC, N2, instead of R, we can write it as sin 90. We know very well that sin 90 value is 1. So we can replace this one by 1. So the next step we can write N1 sin IC is equal to N2, instead of sin 90 we can write 1. Now we are going to get the expression for what is this? Sin IC. Sin IC is equal to N2 by N1. So that is the next step. Now I am going to replace this IC. How IC can be replaced? Look at the triangle. So in this triangle, here that 90 degree is there, perpendicular is there. Are you clear? Now how to get this? How to get this IC? This IC can be obtained by 90 minus RA. From this triangle we can write IC is equal to 90 minus RA. Are you clear? So this is the expression that can be obtained from this triangle. If this 90, if it is subtracted by this RA, you will get IC. Therefore, IC can be replaced by 90 minus RA. So in the next step, we can write sin 90 minus RA can be written, which is equal to N2 by N1. So next step over. We know that sin 90 minus theta is equal to cos theta. Like this, sin 90 minus RA will be equal to cos RA. So this one can be written as cos RA, which is equal to N2 by N1. Now we have obtained the new equation cos RA. Are you clear? We know another equation, fundamental equation, sin square theta plus cos square theta is equal to 1. Like this, we can write sin square RA plus cos square RA will be equal to 1. Like this, we can write the next equation. What is this? Sin square RA can be written. Sin square RA is equal to, how it can be written? 1 minus cos square RA. Are you clear? So here, to get sin RA, what we have to do? We have to take square root on both sides. If square root is taken, I'll write the square root form also. Sin square RA is equal to square root of 1 minus cos square RA. Step by step I am writing, you have to follow it up. Sin square RA, that is taken by square root. So finally what will happen? Sin RA you will get. Sin RA is equal to square root of 1 minus cos square RA. Are you clear? Now we know the expression for cos RA. This cos RA value to be substituted here. Are you clear? In the next step, space is not available. Therefore, I will write the value in the, so clear, in this corner. Sin RA is equal to square root of, there cos RA is there. Cos RA is equal to N2 by N1. But here cos square RA is there. So what we have to do, instead of cos square RA, I am going to write 1 minus N2 by N1 power of square. So in this format we can write. Are you clear? The next step I can write sin RA is equal to square root of, inside you can take square. So this one becomes N2 square and this one is N1 square. Are you clear? Both are squared. So the next step we can write sin RA is equal to square root of, take LCM, you will get N1 square. If it is brought here, that one becomes N1 square minus N2 square. So in that format we can write. Okay. Already we have derived the expression for sin RA. This sin RA can be substituted in the first equation. Very easy one. Now I can write N3 sin IA is equal to N1, instead of sin RA, this entire equation can be written. Now I am going to write this expression N1 square minus N2 square divided by N1 square, it is written. Now this N1 square can be taken inside, that can be brought here. N3 sin IA, if N1 is taken inside, what will happen? That one becomes N1 square. So write square root n1 square n2 square divided by n1 square into, if it is brought inside, that one becomes n1 square. This n1 square can be cancelled. Are you clear? Now this sin Ia, that can be written separately. Sin Ia is equal to this n3, that can be cross multiplied. Are you clear? So what is the remaining factor? Here the remaining factor is n1 square minus n2 square. Are you clear? Divided by, the whole thing can be divided by this one. Which one? n3. In the next step we can write sin Ia is equal to square root of n1 square minus n2 square. If this n3, if it is written within the square root, that one becomes n3 square. So everything is written within the square root. Therefore, this one can be written in bigger square root form. Are you clear? So this is the final expression. Now, here look at here. This is n3 is air medium. Since n3 is air medium, it can be taken as 1. Therefore, n3 value becomes 1. So the next step we can write sin Ia is equal to square root of, after substituting 1, this expression is written in short form, n1 square minus n2 square. Our aim is to get acceptance angle. Therefore, this sign can be written on the other side. Ia is equal to sin inverse of, okay, and then write the remaining thing in the square root. n1 sin inverse of n1 square minus n2 square. So this is the expression called, what is this? Acceptance angle. So what is acceptance angle? After substituting the refractive index of the core and refractive index of the cladding, you have to take square root and you have to take sin inverse of this value, you will get some angle. In this particular angle alone, the light ray that should be made to incident, only then this ray, that one will graze, refracted ray will graze, automatically this angle will become IC. Are you clear? That's why this angle is called acceptance angle. Here the acceptance angle value, that range must be written. Here the acceptance angle is 0. The acceptance angle, that value that varies from 0 to Ia. What is the minimum value of Ia? Ia value must be, minimum value is 0, the maximum value is Ia. So the range of Ia starts from 0 to Ia. Are you clear? Within which you can send the ray, is clear, in between the 0 and Ia, only then the ray will graze. Are you clear? So this is a very important derivation. We have to follow it and derive it. Okay, thank you.